what I'd like you to do is I'd like you to start with C and D. We're finding equivalent logarithmic expressions to those. Okay? So, for instance, what I'm asking is log base 64 of 8 is equivalent to 1/2. What exponent do I have to put onto 64 to get 8? And that exponent would be 1/2. So what I want you to do is I want you to come up with 2 equivalent expressions that are also the same as 1/2. Okay? Alright? Go for it. So give me one. Give me an equivalent logarithmic expression. What we got, Ben? Log what?
Log 256 of 8.
Log base 256 of 8 is not going to work out, no. Give me one. What do you got here?
Log base 4 of 2.
Log base 4 of 2 works out. I like it. Jacob?
Log base 16 of 4.
Log base 16 of 4.
Log base 9 of 3.
Log base 9 of 3. Log base 144 of 12.
Log base 36 of 6.
Log base 36 of 6. Log base 9/4 of 3/2. Okay? Right? All those work. Because all those are equivalent to 1/2. Okay? What about D? Anybody come up with one for D?
Log base 3 of negative 3.
Log base 3 of negative 3 would not work.
Why didn't that work though? Because isn't it just negative 1?
So you're saying that this is equivalent to negative 1, right? Is that what you're saying? Okay. So we're saying that this is negative 1. Okay. So let's switch forms with it then. When you switch forms, what do you get? 2 to the negative 1 power equals negative 2. What is 2 to the negative 1 power? 1/2, right? Okay. So that's not going to work out. So let's go at this one a different way. What if I said this is equal to a box? And I want to fill the box, right? Okay. On C, I filled the box with 1/2. Right? So this would be what in exponential form? 2 to the box equals negative 2. Fill my box. We already tried that one. Didn't work out. 2 to the negative 1 power is 1/2.
Yeah, that'd be 1.
Not negative 2. Put your calculators away. You don't need them.
Yeah. Use your brain.
Yeah.
Yeah.
Hey, your coat's right there.
I found it. Are you guys doing logarithms?
Mm-hmm.
numbers always kind of stump me.
That was a good one the other day.
Guys get it?
Oh.
Oh, is he jiggle as you while?
I didn't even make that one up.
Well-
Christiana Seehafer did. You know
Mhm.
Christiana?
I was there to witness it too.
Yeah.
And we laughed and
And
laughed and laughed.
Math teachers.
Math humor. -4. 2 to the -4 power is 1/16. Not -2. I'm not saying it might help to look back at yesterday's notes, but it might help to look back at yesterday's notes.
Oh,
1/16?
that's-
So if my argument has to be greater than 0, because that's what it says on page 812, which we went over yesterday as one of the key rules. What was the other rule that we had yesterday? Base has got to be greater than 0 and
Not equal to 1.
not equal to 1. Okay? So the base has to be greater than 0 and not equal to 1, and the argument, or we called it the answer to, has to be greater than 0. Right? Okay? Unless there's a horizontal or a vertical shift or a negative a value, but in this case, there isn't a negative a value and there isn't a vertical shift. Okay? So my argument or my answer, this part right here, has to be greater than 0. Is it greater than 0? -2 is greater than 0, Ben?
Never mind. I was like, yeah. that was-
Okay.
that was-
So is this possible? No. There is no equivalent logarithmic expressions to that because it's not possible. Okay? So today we are going to go through and we're going to estimate the value of logarithms. Okay? So what we're going to do, or what you're going to do here in a couple of seconds, is I'm going to do logarithms base 2. You're going to do logarithms base 3, base 4, and base 5. Okay? What this is saying is that -1 on the number line is the same as log base 2 of 1/2. What exponent do I have to put onto 2 to get 1/2? The answer is -1. Okay? What exponent do I have to put onto 2 to get 2, or I shouldn't say it. What exponent do I have to put onto 2 to get 4 is 2. So that's where the 2 comes in. Okay? So 1 would be log base 2 of 2. 1 is the exponent that I put on 2 to get 2. For 0, it would be log base 2 of 1. 2 to the 0 power is 1. For 3, it would be log base 2 of what? Don't say 6. Log base 2 of 8. Do you see a pattern with the arguments? What's the pattern, Alexis? So I'm just looking at the arguments. So 1/2 to 1 to 2 to 4 to 8. Multiple, or we're always multiplying by the base to get the next one, right? So following your pattern, this one should be. Yep, exactly. This is log base 2 of 16. Okay? So I multiply by 2 in the argument to go that way, or multiply by the base, right? Which means if I'm going to the left, I would divide by the base. So this one over here would be log base 2 of 1/4. Okay? Your job now is to fill in log base 3, log base 4, and log base 5 in the number line. Go. So, start in the middle. Log base 3 of 1. So then the next one to the right would be log base 3 of log base 3 of 3. Next one would be log base 3 of 9. Next one would be log base 3 of 27. Oops, hold on, now I got craziness. Log base 3 of 9. Log base 3 of 27. And then log base 3 of 81. Going to the left then, this would be log base 3 of 1/3. This would be log base 3 of 1/9. Okay. On these it would be log base 4 of 1/4, log base 4 of 1, log base 4 of 4, log base 4 of 16, log base 4 of 64, and log base 4 of, oops, I put a 1 there, 256 should be there. On 5s, it would be, so we'll start on the right and work our way back to the left, log base 5 of 125, log base 5 of 25, log base 5 of 5, log base 5 of 1, log base 5 of 1/5, and log base 5 of 1/25. Okay? Looking at that chart, what can you tell me about all 4 of them that are equivalent to 0? What do you mean they're all 1? The argument is 1. So they are all of the form log base b of 1. Okay. What can you tell me about all of the 4 that are equivalent to 1?
They're all equal to b.
What do you mean they're all equal to b? Because they're all equal to 1.
They're the same number as the base.
What's the same number as the base? Got to be a little more specific.
All of the arguments of 1 are the same numbers.
All the arguments are equal to the base.
Yeah.
So they're all of the form log base b of b, right? All the arguments are equal to the base, and that's equivalent to 1. Okay, I would agree with that. Okay, what we're going to do now is on that same chart that you just made there, what we are going to do is we are going to try and plot on the different ones where log base 2 of 18 would fall, where log base 3 of 18 would fall, log base 4 of 18, log base 5 of 18. Okay? So where do you think on the log base 2 line, where would log base 2 of 18 fall? Luke?
Probably after 4.
After 4? Why would you think that it would fall after 4?
Because log base 2 of 18 is higher than log base 2 of 16.
Why?
The argument is higher.
Because 18 is bigger than 16?
Yeah.
Yeah. Okay. Yeah, exactly. Okay. You answered the question with the question again. That's why I made you keep going on. Okay, so 18 is bigger than 16, so it would probably fall somewhere right in here. Log base 2 of 18. Okay? Where would log base 3 of 18 fall? Ben?
Probably in between the 2 and the 3.
Where? Estimate.
Right in the middle.
Why do you think right in the middle?
Because 9 plus 9 is 18. 18 plus 9 is 20.
Because 18 is right in the middle of 9 and 27.
Yeah.
Yeah, I would totally agree with that. Okay? Where do you think log base 4 of 18 would fall? Why closer to 2?
Because it's not quite 64, but it's closer to 16.
Because 18's close, it's 2 away from 16, right? And it's a lot more away from 64, right? So I would probably go a lot closer to 2, yep, than I would to 64. Okay? What about log base 5 of 18? Between 2 and 3?
1 and 2.
Oh no, 1, 2.
Between 1 and 2, closer to 1 or closer to 2?
Just a little closer to 2.
Little closer to 2, so not as tight this time? Okay. All right, see that logic? Okay. On the next page, here we have this like notebook type thing, which takes up the majority of your page. Okay. It says estimate the value of log base 3 of 33. Okay. To estimate that log to the 10th place, identify the closest logarithms whose argument is less than 33 and the closest one who's greater than 33 that represent the base of 3. So what you would choose then here is you would choose log base 3 of 27, because 27 is the highest power of 3 less than 33. Okay? And log base 3 of 27 is equal to 3, or is equivalent to 3. The power that I need to put onto 3 to get 27 is 3. Okay? So that's the left side. Then we go to the right side. Then we pick the next one that's bigger than 3. So since we went 3 cubed for the left one, that means we're going to go 3 to the 4th power for the right one. Okay? 3 to the 4th power is 81. So log base 3 of 33 is somewhere in between 3 and 4. Okay? So because 33 is closer to 27 than it is to 81, our value is going to be closer to 3 than it is to 4. So we'd pick somewhere probably in the 3.2, 3.3 range. Okay? Tomorrow, we'll utilize our calculators and we'll get exact values for log base 3 of 33. But today, we're just estimating. Okay? What I'd like you to do now is, well, here, so Silas and Sutton were estimating log base 4 of 28. Sutton did it the way that I just showed you. Silas did it by looking at the powers and then also going, so he's looking at 28 between 16 and 64. Again, done the exact same way. What I would like you to do now is on page 819, I would like you, well, let's do A together and then you guys can do B, C, and D. Okay? So log base 2 of 10. Is going to be in between what? What is log base 2 of 10 in between? Log base 2 of 8 and log base 2 of 16. Log base 2 of 8 is 3. Log base 2 of 16 is 4. So it's somewhere between 3 and 4. Closer to 8 or closer to 16 is 10? Closer to 8. So I would probably go in the, it says rounding to the 10th place. I would probably go that log base 2 of 10 is approximately 3 point, I would say 3. Because it's about a quarter of the way there. So that's like 3.25-ish, so let's go 3.3. With me? Okay. You now do B, C, and D. Thorns, what did you pick for log base 5? Hold on, I got to write down log base 5 of 4 in red. Log base 5 of 4. On the left side, you picked? Log base 5 of 1. And on the right side, you picked? Log base 5 of 5. Okay? And then you said that log base 5 of 1 was 0, and log base 5 of 5 was 1. So 4 is closer to 5, right? And you picked 0.9. Okay, I would agree with that. So log base 5 of 4 is approximately, whoa, tap the brakes, things are moving around. Log base 5 of 4 is approximately in that 0.8, 0.9 range. Yep, okay, I would agree with that. Everybody else agree with that? Okay, good on that one. Log base 4 of 300. So log base 4 of 300. I'm going to quick just do log of 2500 right away too, as long as I got the red marker going. Okay, is in between what? Log base 4 of what? Of 256 and 1024. So log base 4 of 256 is 4. Log base 4 of 1024 is 5. Now, the difference here is 44. The difference here is 724, right? So I would say, as an estimate for me, I would say log base 4 of 300 is approximately 4.1. Yes? Yeah. I don't know if I'd go more than 0.1. Maybe to 0.2, but I would for sure wouldn't go any farther than that.
With the calculator, could you just divide 724 by 44, and then that would give you a decimal?
No. Okay. Log of 2,500. What's the base first? The base is 10. Okay. So The power of 10 smaller than 2,500 is 1,000. The power of 10 larger than 2,500 is 10,000. Because 1,000 is 10 cubed.
Yeah, I don't know what.
Because there's 3 zeros. This is 10 cubed. So that's an exponent of 3. And then this is 4. Because there's 4 zeros. Did you ever know that?
I don't know what you're
The question that you asked is how did we get 1,000? Okay? And 1,000 is 10 cubed. Okay? Because there's a 1 and 3 zeros. Okay? Right? Which means that log of 1,000 is 3. Okay? Right? So, closer to 3 or closer to 4? 3? 1,500 as opposed to 7,500. I'd probably go log of 2,500 is in that, what are you going to say? 3.3 range? Okay. I'll buy into it. Okay? Yeah?